Welcome to the session on finite differences. In the last session, we discussed two operators, forward difference operator and the shift operator. Now, here we shall discuss some relation connecting these two operators, that is the forward difference operator and shift operator. The forward difference operator is defined as delta f of x is equal to f of x plus h minus f of x, where h is the interval of differencing. The shift operator is defined as E of f of x is equal to f of x plus h. From this, we can write delta f of x is equal to f of x plus h is E of f of x minus f of x. That is equal to E minus I of f of x. That is delta is equal to E minus I. I means the identity operator, or E is equal to 1 plus delta. The next identity is E delta is equal to delta E. We have E delta f of x is equal to E of, by definition of delta, we can write f of x plus h minus f of x. That is equal to E of f of x plus h minus E of f of x. This is equal to, by definition of the shift operator E, we can write E of f of x plus h is equal to f of x plus 2h minus E of f of x is equal to f of x plus h. This is equal to delta f of x plus h. By definition of delta, we can write f of x plus 2h minus f of x plus h is equal to delta f of x plus h. That is equal to delta, this is E of f of x. That means E delta is equal to delta E, which is the second identity connecting the shift operator E and the forward difference operator delta. Now, we have to prove if n is a positive integer, then yn is equal to y naught plus nc1 delta y naught plus nc2 delta square y naught plus etc. plus ncn delta raised to n y naught. By the definition of shift operator, we can write y1 as E of y naught. That is equal to 1 plus delta. We just proved the identity is equal to 1 plus delta. We use the identity here, E equal to 1 plus delta y naught. That is equal to y naught plus delta y naught. y2 is equal to E square y naught. We have yn is equal to E raised to n y naught. Therefore, we can write y2 is equal to E square y naught. That is equal to 1 plus delta square y naught. This is equal to 1 plus 2c1 delta plus delta square of y naught. By the expansion of 1 plus delta whole square, we can write 1 plus 2c1 delta plus delta square of y naught. That is equal to y naught plus 2c1 delta y naught plus delta square y naught. Similarly, we can write yn is equal to e raised to n y naught, that is equal to 1 plus delta all raised to n y naught, that is equal to, by the expansion of 1 plus delta all raised to n, we can write 1 plus nc1 into delta plus nc2 into delta square plus etc. plus ncn, ncn is 1 delta raised to n y naught. That is equal to y naught plus nc1 delta y naught plus etc. plus delta raised to n y naught. Hence the identity, that is yn is equal to y naught plus nc1 delta y naught plus etc. plus delta raised to n y naught. Now, we have to work out some problems. First problem is to find the missing term of a given data. We can use the identity we proved. The question is find the missing entry of the following table, that is the x values are 0, 1, 2, 3 and 4. The corresponding y values are 1, 3, 9. Entry corresponding to 3 is missing and the y value corresponding to 4 is 8. Sorry, this is 81. Now, we have to find out this missing entry. Here 1, 2, 3, 4, 4 values are given, that is y naught is equal to 1, this can be taken as y naught, y1, y2, y3 and y4. y3 is missing and the 4 values are given. Therefore, we can assume that the fourth difference onwards are 0, that is delta raised to 4 y naught equal to 0. By the identity, we have delta is equal to e minus 1. This implies e minus 1 raised to 4 of y naught is equal to 0. Implies e raised to 4 on the expansion of e minus 1 raised to 4. We can write e raised to 4 minus 4 e cube plus 6 e square minus 4 e plus 1 of y naught is equal to 0. Which gives e raised to 4 y naught minus 4 into e cube y naught plus 6 into e square y naught minus 4 into e y naught plus 1 into y naught is equal to 0. That is y raised to 4, sorry, y4 minus e raised to 4 y0 means y4. By the definition of shift operator, we can write this as y4 minus 4 y3 plus 6 y2 minus 4 y1 plus y naught is equal to 0. We use the definition of shift operator in all the terms. We write this, which implies by the substitution y4 is y0, this is y0, y1, y2, y3 and y4. y4 is 81 minus 4 into y3 is missing, plus 6 into y2, y2 is 9, minus 4 into y1 is 3, plus y0 is 1 is equal to 0. On simplification, we will get y3 as y3 is equal to 31. y3 is equal to 31. That is, we used the identity connecting the forward difference operator delta and the shift operator to find out the missing entry in the given data. The next problem is find the first term of the given series whose second and subsequent terms are 8, 3, 0, minus 1, 0, etc. We have f of 2 is equal to h. This is the second term. Third term is 3, f of 3 is equal to 3, f of 4 is equal to 0, f of 5 is equal to minus 1, f of 6 is equal to 0. These are the given values. We have to find f1, the first term we have to find. We construct the difference table using the given data, that is the x values are 2, 3, 4, 5, 6 and the corresponding y values are 8, 3, 0, minus 1 and 0. The first differences are 3 minus 8, that is minus 5, 0 minus 3 is minus 3, minus 1 minus 0 is minus 1, 0 minus minus 1 is plus 1. These are the first differences. The second differences are minus 3 minus minus 5, that is 5 minus 3 is 2, minus 1 minus minus 3, that is 3 minus 1 is 2, 1 minus minus 1 is 2. The third differences are 2 minus 2 is 0, 2 minus 2 is 0 and the fourth difference is 0. From this difference table, we have delta cube y means f of x is equal to 0 and delta 4 f of x is equal to 0 and the all other differences are 0. By using the displacement of that means the shift operator, we have the by definition we have E inverse f of x is equal to f of x minus h. That is f of 1 is equal to is e raised to minus 1 f of 2. By using this definition, f of 1 can be written as e raised to 1, sorry, e raised to minus 1 f of 2. That is equal to 1 plus delta raised to minus 1 f of 2. That is By the expansion of 1 plus delta raised to minus 1, we have 1 minus delta plus delta square plus delta cube plus etc. of f of 2. That is equal to, this is equal to f of 2 minus delta f of 2 plus delta square f of 2 minus delta cube f of 2 plus etc., which is equal to f of 2 is 8 minus delta f of 2, that is the first difference. F of 2 is 8 minus delta f of 2 is minus 5 plus delta square f of 2, that is the second difference, that is 2 minus 0 plus 0 etc. That is equal to 8 plus 5 is 13, 13 plus 2 is 15. That is f of 1 is equal to 15. The first entry or the first term of this sequence is 15. We used the relation connecting displacement of operator and forward difference operator. Now, we can find out more missing terms for a given data. The problem is interpolate the missing entries of the given data. The values of x are 0, 1, 2, 3, 4 and 5. And the corresponding y values are 0, this entry is missing, 8, 15, this also missing, and 35. The first value of y can be taken as y naught, this is y1, next is y2, y3, y4 and y5. Here two entries are missing, that is y1 and y4 are missing. We have to find these two missing entries using the relation connecting E and delta. Here 1, 2, 3, 4, 4 values are given. Therefore, we can assume that the fourth difference onwards are 0. That is delta raised to 4 y naught equal to 0, which implies e minus 1 raised to 4 of y naught is equal to 0. We proved delta is equal to e minus 1, the identity delta is equal to e minus 1. By expansion, this implies e raised to 4 minus 4e cube plus 6e square, 4e cube plus 6e square minus 4e plus 1 of y naught is equal to 0. That is e raised to 4 y naught minus 4 times e cube y naught plus 6 times e square y naught minus 4 times e y naught plus 1 y naught is equal to 0. By definition of shift operator, e raised to 4 y naught is y4 minus this is 4 into e cube y naught is y3 plus 6 into y2 e square y naught is y2 minus 4 y1 e y naught is y1 plus y naught equal to 0, which implies by the substitution of values of y, y4 is missing, y4 is unknown, minus 4 into y3 is 15, 4 into 15, plus 6 into y2, y2 is 8, minus 4 into y1 is missing, that is unknown, plus y0, y0 is 0, is equal to 0, which implies y4 minus 4y1. By simplification, this is equal to this is minus 12, that is equal to 12. We obtain an equation in y4 and y1, that is y4 minus 4y1 is equal to 12. Also, we can write delta raised to 4y0 is equal to 0. The fifth difference also equal to 0, which implies e minus 1 raised to 5 y0 is equal to 0. On expansion, we get e raised to 5 minus 5 e raised to 4 plus 10 e cube minus 10 e square plus 5 e minus 1 of y0 is equal to 0 by the expansion of e minus 1 raised to 5, which gives e raised to 5 y0 is y5 minus this is 5 y4 plus 10 y3 minus 10 y2 plus 5 y1 minus y0 is equal to 0. Substituting the values of y, we get y5 is 35 minus 5 into y4 is missing plus 10 into y3, that is 10 into 15 minus 10 into y2, y2 is 8 plus 5 into y1, y1 is missing minus y0 is 0, that is equal to 0. On simplification, we will get y4 minus y1 is equal to 21. We obtain another equation in y1 and y4, solving these two equations. This is equation number 1 and this is 2. On solving for y1 and y3, we obtain y1 is equal to 3 and y4 is equal to 24. That is, the missing entries are y1 is 3 and y4 is 24. Let me conclude this session. In this session, we discussed some relations connecting the forward difference operator delta and the shift operator E. We can use the identities connecting this delta and E to interpolate some missing entries of a given data. Thank you for watching this session. Thank you.